Yeah, good morning, good afternoon, good evening to people over here. I mean, this is definitely a very exciting forum. I'm very glad to be here to meet so many talented students and to share what we have over here. And I was told this was a 45 minutes talk, so I prepared a little bit more content than 20-ish minutes I can finish. So I'm probably going to jump a couple of slides over here. And just feel free to let me know if you have any question in the middle. So, yeah, what I'm trying to share today is basically some history about how everything been evolved so far in deep neural networks and large language models over the past years, and also what happened actually over the past year, and then to a little bit forward looking to what will happen in the coming future. And of course, everything is related to deep learning, neural networks, and language models and agents. These are basically probably the hottest topic in industry at this point. Um, so quickly look back on what actually happened over the past, I would say, 14 years. But of course, like deep neural network has a long history. I think the first one being invented in history was back to like 1940s. But until like 1980s, when Jeffrey Hinton started looking into this one, he invented this so-called backpropagation algorithm. It started working, but still not as one of the most interesting topic for computer science scientists. But until I think in 2012, when Jeffrey Hinton had a student called Alex, he introduced something called AlexNet. First win a competition called ImageNet, which is doing image recognition with a large amount of image. And he actually won the competition by far compared to the second place. This is basically the first time people realize that deep learning is uh, kind of the future of machine learning. And I mean, all the industry has started putting more resources into this direction. And of course, you guys see uh, another speed up in terms of momentum when OpenAI announced ChatGPT back in 2022. But I would say like over the past 14 years, there's lots of great stuff have been developed. I'm not going to go deep over here, but this is I would say one of the most exciting moments in history, and I feel very lucky to be part of the journey right now, and I feel very lucky that um, you guys actually are already looking to this one. And I mean, from the introduction I've seen, you guys are already doing a lot of great work inside this area, and there's definitely a lot more exciting moments coming in the coming years. Um, I'm not sure if you guys have read this book. There's some the book called like Thinking Fast and Slow. I'm not going to go deep over here. If you didn't get a chance, I think this is actually a very good book to explain how human brain works. And you will be able to see like lots of stuff we've been doing right now in machine learning in AI agent area. It's very much mapped into these two different systems built up in human brain over the past thousands of millions of years. So um, skip that part a bit. I would say another key moment over the past year is in April 2025, OpenAI released OP3 model. It's not only just like a thinking model, it's a model that knows how to use tools. So when you connect all these deep learning models with tools, you actually created a very different system. And that's how AI agent become super, super hot over the past year. So in general, the whole industry has been moved from just to further scale out large language models to a different size or different architecture towards building up different systems that knows how to use how to use tools, and to complete a lot of very complicated tasks. Um, and I guess probably everyone knows how to define AI agent at this point, but just to go through this a little bit, think that we looking now we define agent as a system that combine with large language models and tools. And so instead of just you throw a question to large language model and get response from it, What happens right now is you basically throw a question to a system. The system knows how to use large language model to reason, to plan, to do a bunch of stuff with tools. And depending on how the response from the tools, what kind of next step you want to do, then it actually does iteration inside the system until it gets a very good result for you, or it requires some further clarification question for you. So this is the system has become more and more complicated. It started with a simple system with one or two tools, but I think right now, like the major coding tool, coding agent can already be handling a lot of like tens of hundreds of tools at the same time and can automatically pick which tool to be used for the next step. So this is, I would say, a very rapidly developed area, and we should be able to see a lot of like forward progress in the coming years. Um, in 2025, I would say like there are definitely lots of exciting moments, but there are three moments I actually feel like this is going to be important or critical and also strengthen people's belief that AI agents will become a thing for the future. So the first one is basically in July 2025. I think not only just one model, I think we have multiple models that achieved the gold medal performance in IMO. I guess everyone knows what IMO is. That's International Mathematic Olympiad. It's probably one of the hardest problems, a set of one of the hardest problems in the world. And IMO gold medal performance means AI models can achieve the level of deep thinking and reasoning than 99.99999% of human in the world. It's basically a level of intelligence that most of people cannot achieve. So the second one is the coding agents become super successful over the past year. We start playing with GitHub Copilot, I think, in late 2024. It was good. It was not that good, right, comparing to all the other coding agents we have right now. So if today you start using GitHub Copilot, you use our Cloudy Code to do our coding work, it basically just give it a command. It can automatically finish a lot of stuff for you without any interaction from you. And I think 2 weeks ago or 3 weeks ago, Cloudy Code even set up like a record that it can run itself for 4.5 hours continuously without stopping, just to finish a very complicated project. Um, I think this is basically setting the competition to the next level. We no longer talk about the question whether the coding agent can code reasonable code for you. It's now we are talking about what are the stuff coding agent cannot complete for us for now. And I assume lots of gaps can be even closed within this year. So the third part, of course, is the release of DeepSeek R1. I guess this is one of the most exciting moments in the open source community and also in the research area because, I mean, before that, we are talking about OpenAI's open model or other deep thinking model, but it's not open source. But the DeepSeek R1 model actually opens the door for everyone in the world that you can easily access to these deep thinking capabilities and also let other people know that, okay, these models can be achieved within the open source community. So over the past year, actually, you probably also like a lot of other open source models already achieved better performance compared to DeepSeek R1. I would say like with all these open source models, the gap between closed models and also closed source models and open source models are actually very small at this point. And this actually, I would say, open a big gate for everyone in the world that can enjoy the technology advancement over the past years. So with these three success moments, I would say people have very strong belief that AI agents will be a thing, a very critical thing for everyone in the world in the coming years. I'm going to skip this part, but I guess you guys can do some like offline like research if you haven't seen this one before. This is a very nice quote from Jason Wei, a former OpenAI researcher, to define what kind of problem can be easily solved by AI. And he actually wrote a blog talking about this one. So it's a very nice one. I would recommend to read it. I'm not going to talk about this one today. So talking a little bit about how these AI agents being trained, it's very much like how we coach a kid to learn a new skill. So usually we go through like two steps. The first step is something we call supervised fine-tuning. It's basically just the same as how we coach a kid to learn how to do like forehand, backhand, volley, serve, these basic components of a tennis game. Of course, if without knowing these techniques, you can still play, but you're not playing the right way. So this is very critical. But once you pass the first step, a major one, the major task to finish to further coach the kid is basically just throw it onto the court to play with someone else, and then you have someone on the side to give the like continuous feedback. Say, okay, you are doing this great. You need to improve here. You need to improve there. So this is something we call reinforcement learning with human feedback. And that one is basically the core idea behind lots of the large language models like ChatGPT. Um, and in fact, OpenAI and other companies hired a lot of people to provide this human feedback to feed into this reinforcement learning to further improve the model quality. And of course, right now we are pushing this one to the next level. We're no longer uh, like 100% relying on human feedback, but instead we are largely relying on like AI to give us feedback that could further like speed up the training speed and efficiency of the large language models. So just give a quick idea about how everything's been looking like right now. Um,
Hey,
so
Mr. Xiong,
yeah.
just really quickly, there was a question asked. Can you explain again what is SFT?
So SFT is supervised fine-tuning. So the idea is basically you provide a bunch of input and output pairs to a system. Say every time you see this image, you should be responding as a cat. And then you see this image, you should be responding as a dog. So this is like one-to-one mapping. You're just teaching the basic idea about this mapping. And there's no reasoning, no thinking. It's like instant response.
Great, thank you.
Yeah. So, talking about what actually matters at this point, I would say over the past years, we built up lots of good reinforcement, we have lots of good open source foundational models. We have lots of good open source, like reinforcement learning frameworks. So, when you look at the industry, there actually is the three areas that's going to be very hot, is very hot at this point, which relate to data, grader, and reinforcement learning infrastructure. So actually, I would say lots of work over here is very much like a teacher is doing to their students. So just imagine I'm a teacher teaching a group of students to learn geometry. And what I'm trying to do over here is going to find the right curriculum to teach in my course. Then I need to define a bunch of tests to test how good my student is. And I find a better way to grade their regular test, their homework, and define a final test to see whether pass or not. So very much work from our scientists, very much time for our scientists being devoted to these two areas at this point. They're trying to find the best data to train the models, to train the agents. Trying to find the best grader to be used to evaluate the quality of these agents. And these two are actually super, super important at this point because these two are actually directly associated with the quality of the agent being generated at this point. And of course, reinforcement learning infrastructure is very important. I'm going to skip that part at this point. I want to show you guys a very interesting a study some of my colleagues did over the past year, which is something called one-shot reinforcement learning with verifiable rewards. So imagine I just talk about supervised fine-tuning. The idea is basically you have a group, a lot of images for also a lot of input paired with output. Then you just do one-to-one mapping. You try to teach the model to learn. And usually for that one, you need to provide a lot of data because only with one image, you cannot really learn too much, right? So traditionally, especially talking about large language model training, we're talking about trillions of tokens. I think the largest record in history is about like 15 trillion of tokens when it's being trained, one of the largest model in the world. Um, so people cares about the size of the data, the amount of data. But when it comes to AI agent training, we find that the quality of the AI the data is more important. And in this paper, actually, what the researcher did is they only pick one data sample. I think in total they have like 1,200 of problems or math problems to be used to train the model. They can achieve certain level of quality. But the researcher actually find that even just with one sample, one problem, just repeatedly ask the model to solve this single problem, they still find the model can learn a lot through this learning and actually achieve a quality very close to or can be achieved with the whole like 1,200 samples. So this is actually a signal just to show everyone say, hey, at this point, we care more about the quality to be feeding to the system. Um, Another interesting stuff I want to show over here, actually, I'm not sure if you guys can see it. Um, Let me just click this one. Oopsie. Wait, why it's not working? Oh, okay. So another thing is, I would say this is something like DeepMind already found in 2018 when they tried to train AI agent to do StarCraft. I'm not sure how many of you have been playing this game. This is basically not a typical strategy you will use by a human. It's basically pulling all the workers they're using to attack the other side of the enemy. But agents actually find out it's super efficient with attack doing like a 1v1 towards another like AI from Blizzard, which don't know how to defend this kind of attack. So this is just to show that AI agents are super smart. They can find a lot of holes in your grader. So I would say a lot of work the researchers are doing right now is really to fill these holes so they can teach the agent to do the right thing. um, but just this is just to show an example, like if you don't do the proper way, the agent can find a shortcut to just bypass or grader, do something you don't expect. Um, I probably want to go through this one very quickly because I feel like this could be very important to think about when you think about how agents are going to be trained in future. So we kind of try to compare the similarity of the process how we hire a new grad to a company to how we onboard an AI agent to a certain task. So imagine uh, usually in a big company like Microsoft or Google or Meta, we will hire people. So we are looking to people's resume and we'll do an interview and to make sure, okay, these are the smart kids we want to hire into the company. And then once we got a person into a company, definitely they have lots of background knowledge about what's being studied in college, but most likely it's not going to be the same to be used in the company. So we want to give them the onboarding task in the company's environment, and once you finish that, you start learning how to do the real work, how to play with the real like production environment we have in a different setup in a different company. And of course, over the time, over the years, we provide continuous coaching from managers or from peers to this person, so we keep help them to grow as a professional. So we see that as a very similar pattern now to get a AI agent start working in a certain task. So basically, we start selecting the model based on its like capability. So we do have a lot of different models we can choose. Some of the models are very good. Some of good models are less efficient, but they are actually very good specifically in some of the domain. So we pick very carefully based on their like fundamental capabilities. And then we throw it into a reinforcement learning playground to train the agent specifically toward the task we want to accomplish. We provide the tools they need to be used. We provide the environment. We provide feedback So the agent can keep learning until it passes a line. We say, okay, you're good enough to get into production. But of course, we'll do continuous production feedback based on how our customers been using it, but based on the feedback when people start looking into the trajectory, how the agent's finishing all the everything. We provide this feedback, and the feedback will be used to further improve the quality of the agent. So these are actually very similar process as we're talking about AI agent at this point. Um, we don't have too much time. I'm going to just quickly look forward to seeing what we are going to, what we could potentially see in the coming years. So of course, we will see larger and deeper models. This happens every year. I would say like almost every month at this point. We start talking about multi-agent. Multi-agent is not that efficient over the past year, but it could be more and more efficient when people start figure out what's the best way to let agents working with each other. As I said, we start seeing like long execution, like coding agents over the past year. Cloudy set the record at 4.5 hours. I would guess by the end of this year, we should definitely be talking about days or months. Um, I don't know what time it will be, but it will be a very interesting number to measure the capability of the agents. And of course, we'll be start seeing lots of domain-specific agents. We already have agents that knows how to write code. We should be able to see lots of agents that can, like, for example, do healthcare, do like law, document preparation or suggestions, and like do finance, etc. So lots of like investment of industry is going toward that direction. Um, these are a couple game changers. I feel like if we see some breakthrough in these areas, that could fundamentally change what's going on or what will happen in the coming months or coming year. So first of all, I think you probably heard something from internet already that we are running out of data. So basically, if you look at how the new foundational model being trained, it's basically already constrained all the data they can find on industry. So a large portion of the work is now moving towards how can we generate more synthetic data to better fit the needs. And it's not only just to train the foundational model, it's also being to generate the right data to train the agents. We want it to finish some specific task. And as of today, I would say there's a lot of work that have been done, so there's a lot of progress, but we still don't have a perfect solution. So if anything, if one day we say we have a very good pipeline that can continuously generating high quality synthetic data towards certain given task, that will be a big game changer. Um, and also the second part is like reinforcement learning training itself is not stable at this point. And I think lots of research has been putting on lots of idea about how to further improve that. It does improve over the past 7 to 8 years. And if we can further make it super stable, that will just speed up a lot of progress to get the new agent into production. Self-improvement, as I said, you have something running in production. How can we just make the agent improve itself without go back to human? That would be a very interesting topic. That would be a very dangerous topic as well, because when the agent can improve itself without human in the loop, sometimes you don't know what will happen. The fourth point is actually a very interesting topic raised out by Andrej Karpathy. I'm not sure if you have heard about him. He's used to be in OpenAI and has been working for Tesla as well. He was thinking about like, okay, large language models is growing too big. And a larger portion of the model weight is being used to store the knowledge and information that's not related to any of the reasoning stuff at all. So if there's a way, we can really just like remove all these unrelated weights just to have a core model that's probably like 30 billion or like even smaller, but super good at reasoning. Then we could potentially have a core for everything we can plug into. So that could be a super interesting topic, but I'm not sure if it will be happening anytime soon. Um, this is my last slide. So in general, I would say,
Sorry, Mr. Zhang. There was a question on that slide.
okay,
Um, by Nixon from Nepal. It said, Sir, does synthetic data address the problem of AI training on AI data?
Uh, yes, I think that's what I'm talking about. Yes, what I'm talking about is basically generated data to better serve the training.
Okay. Hope that answers the question. Thank you. Oh, and one more question. Sorry. Do you think there's a limit to how big a model can get regarding parameters?
Um, I think there should not be a limit, but there's a limit of computation resource and how much money people want to put into, right? So right now, if we say we want to train a foundation model, it usually requires, I would say, 20,000 or more GPUs and to be run for like 3 months or something like that. It's super expensive, right?
Hmm.
And so at some point, people are actually looking to a different way to scale out the capability of a model, which is to increase the length of the token being generated by the model, right? So the thinking part. So I would say before the thinking model being introduced by OpenAI, people are still trying to scale the model larger and larger, 10x every year. But now we're really looking to like how we can further improve the chain of thoughts, how we can further improve the reasoning and tool usage instead of just further increase the size of a model. We see this as a different way of a different way of understanding of the scaling law at this point.
Yeah. Okay. Thank you.
Yeah. So yeah, just to conclude a little bit, I would say like we are in a evolution, and this is also the first time in history we see something different than human on this planet that's smarter than us. So it's definitely very dangerous and but also could be very exciting. So I guess we are just at the starting point of this evolution, and we should be able to see lots of great stuff coming out in the coming years. It could be very exciting, and hopefully, it will just lead us all to a very bright future. So, okay, thank you. I will just stop here and see if any questions.
Could we do our questions, the ones that we sent you ahead of time, if that's okay?
Sure.
Great. Okay. So
Felipe, I'm sorry. Can you give me one quick second? I think there was one more question in the chat or two questions in the chat before we move into those questions. Um, uh, Himangzu from Nepal said it was relating to that. Do you think there's a limit to how big a model can get regarding the parameters? His second question to that was, how would AI improve if their size can't be increased?
So that's actually a very good question. It really depends on how you see these scaling laws and how efficient we see these parameters already being used in these model weights. So there's no evidence that we are already using 100% of capability given the size of model at this point. So there are definitely rooms. Just for example, if you compare OpenAI O1 model, sorry, I should not use this example. If you compare DeepSeek V3 model and DeepSeek R1 model, these are basically the model with the same model weights. But DeepSeek R1 is much smarter. It knows how to deep think. But DeepSeek V3 is generally another like a pre-trained model. So it's basically just saying that by using different training mechanism, training data, you can make a model smarter without increasing its size. So
Okay.
I think that's the focus of the industry at this point.
Okay, great. We do have two more questions in the chat before we move on to Felipe's question. The next question is from Anabuva, from he's Nepal senior chair. Um, he asks, uh, but can synthetic data be considered on par with the data that AI has trained on initially? Does that degrade the quality of AI response if fed into a large amount?
So at this point, I think I would say it depends. It depends on what kind of data we're talking about. So we do have some good strategy to generate some good data in some of the domains. So for example, for math problems, I think we do have pretty good synthetic data generation pipelines that we can generate math problems that's different to what you can see before. And it's reasonably interesting and challenging for the model to train on. And that's also some of the, I would say this is also some of the secret sauce for some of the math models in industry at this point. So we do have see some success over there. But in general, if you talk about broader domains, like legal or medical, these are still the areas that we didn't see too much success at this point. And I guess there could be more interesting stuff coming out in the coming years. So um, I'm not sure if I answered the question, but I would say this kind of a mix at this point.
All right.
Sorry. Last one from um, Ardahya in India. Sir, how can we define evolution amongst AI? Like if we say an AI model is to be evolving, what are the changes observed? So how do we define evolution among AI?
So I would say like this knowledge of about model itself is about how we are going to work in the future, like how we interact with the environment, how we as human interact with all the tools we have and all the systems we have. And I mean, of course, AI model may evolve itself at some point, and that's very dangerous, as I said.
Mm,
But as you can already see, like within 2025, the way how computer programmers do their work has been fundamentally changed. Previously, right, I mean, for some of the feature, you have to finish, like for example, in like a week with three people. Now usually you can just finish that with just a couple of like prompts talking to the GitHub Copilot or Cloudy, and they can just write that for you in like 20 I would say 10 minutes or something like that. Right. So this is basically um a different way to work. And you can imagine when people start using the similar strategy to do other stuff in your life, the way you live will be different. The way you interact with the environment and with all the other system will be very different. And I'm not sure it will just change us fundamentally to a different setup. So um, it's hard to imagine. Um, but that's
yeah.
also why I call it as evolution. It will just completely change how you do stuff.
Yeah.
Yeah.
Okay. Thank you very much. All right, Felipe, your turn. Thank you.
Okay, so we know that we're relatively limited, so we'll ask a few questions. And there is one that one of our students is doing a research project, so he's particularly interested in something. But one of our questions is, how do you see language AI evolving architecturally? Do you think transformers will remain the dominant paradigm, or do you expect language models to move toward fundamentally different representations of text? For example, treating text as richer algebraic structures, like a graph rather than a sequence of tokens?
So this is a very good question, and I would say eventually it will, but it's just a matter of time, right? So there's not going to be a architecture which is running forever. But transformer is very hard to replace, not only just because it's already been proved super efficient, but also like the whole industry has been building up like the ecosystem around it. And unless there's something much more efficient, much more powerful than transformer, then that could be another change. But at this point, all the systems, all the like chips, all these inference algorithms are built up around transformers. So I would say this one will be pretty hard to change. But on the other side, you probably can see that the transformer we are using right now is actually a little bit different to the transformer being invented in 2017, and it's actually keep changing over the years. People actually, keep changing how attention works. Like we have different mechanism of attention being introduced over the past several years. We have like a DeepSeek just published a paper 2 weeks ago talking about something called Ngram. If you guys got a chance to look into that, it's basically a different way to embed memory into the system and then save a lot of the space for transformer to remember. So this kind of innovation will just keep coming into the system with transformer as a backbone of the system, but the microsystems, the micro components will just keep changing. So Yeah, I would say there will be a lot of new innovation coming in the coming years around that.
Um, Thank you. And then the other thing is before I ask this question, at Language AI, do you work with audio to some extent? Because I know that you worked with the, oh wait, no, of course you do. Yeah, you made the speech recognition system. So I'll ask the next question. So beyond text, how do you see models for interpreting linguistic patterns from audio evolving? What approaches or architectures do you find most promising today for creating robust audio-based models at Microsoft?
So I cannot say what's working for Microsoft. I just probably say what I can see for industry. So of course, everything is moving towards the end-to-end model. So at some point, you will have an end-to-end model that takes audio as input, gives audio as output, and we do have this kind of model already from OpenAI from Microsoft. Um, but the mainstream of the industry right now is still a cascading model. You have a text to speech, sorry, you have a speech to text, then you do large language model, then you do text to speech to generate output. The main reason behind that is still like, people still find the large language model inside a end-to-end system for speech in, speech out is harder to train. There's lots of like more limitations around that, but I think that will just be overcome in the coming years. Um, I think it's a similar thing actually. We saw similar pattern over the past several years when before large language model era, before, I mean, speech recognition is basically a kind of a problem being solved for like 30 years, 30, 40 years. So it was like a trend towards a cascading model structure, towards a end-to-end model solution. And it's proved that every time you move to end-to-end, as long as you have enough data, you have the right computation power, and then you have the right algorithm, then it's always proved that you will be able to beat the previous system. So I'm actually very optimistic toward this end-to-end system for this audio-based like AI system as well in the future.
Thank you. Now there are just three more. So I'll ask one as a follow-up to this. So one of our organization members is currently making a model for an indigenous language. Fortunately, there is not a lot of like text of the indigenous language. There's a lot of speech though. And so his question was, how might you approach trying to train a model on indigenous language with virtually no standardized writing system, but possibly like a pretty solid like audio system, like not audio system, but like obviously like you can like speak.
So I would say this is a very interesting problem. So something we call low resource language, and it's usually a challenge for sure comparing to all the other languages we have. So there are a couple of findings. So first of all, um, many of the language actually have similar patterns. So if you fine tune a model based on an existing like a model that knows how to handle a language that's very similar to this language, usually you will find a better solution. So this is something when we do machine translation, we actually group a bunch of like low resource locale together and we train a model, we train a joint model, and the quality is usually better than anything else when you train the model separately. So if you can identify a couple of languages that's going to be similar to this language, that will just give you a better quality when you look into the output. So the second part is in speech recognition, there's definitely ways so there's definitely like intermediate steps comparing to in between of a pure sound and the text. So there's something called we call synum, which is to break down the sound into different small components. Then we use these small components to combine them together to generate a full like a word or like a phrase. So, and there's definitely a mature way to do the signal generation. So there's definitely algorithm to say, by combining a bunch of sound together, you segment them, and then you run the algorithm to cluster them together. You cluster them in a way that's going to be the sound could be listened to, similar to each other. So there's a very mature system to do that. So I would recommend. So if we don't have very good text for this audio at this point, you may try to see if you can find the intermediate representation of these sounds. That could be another idea you can try, and maybe that would be easier compared to just like directly translate from a sound to a text.
Great. Thank you so much. Now here are last two questions. So our organization is largely focused on reducing the learning time necessary for high schoolers to understand advanced models or advanced machine learning concepts. As stated previously, we've been doing work with physics-inspired machine learning, graph neural networks, geometric deep learning, and transformers. What topics do you think we should explore next?
So as I said, reinforcement learning is definitely one of the most important thing you guys want to take a look. Of course, you want to look into supervised fine-tuning, reinforcement learning, um, and uh, um, and these two, I would say, you should be able to find very good resource online and very good framework that you can use directly. And the reason why I say this one is basically this is basically the foundation for the future model and large model training, agent training for sure. Um, and of course, I already see like you guys are going to look into LoRa's fine tuning. This is great because I think this is definitely one of the easiest way to get something working um, within existing large language model without too much requirement on the GPUs. Um, so once you finish that, you might want to look into a little bit deeper into like the training like efficiency, etc. But that's going to be a deeper topic. Um, from another point, I would also want to ask like what kind of goal do you want to achieve, right? Because sometimes we want to teach people how to use how to train models, how to apply this deep learning knowledge into a model training process. Sometimes we want to teach people how to better use these technologies in different areas that's going to make their life easier. So are you going to cover both or are you just going to focus on the model training part?
So as I said, our goal has like our organization has a very like diverse set of like mathematic and like coding talents. So essentially our goal is sort of to teach them both the math, the intuition, and the code or like training of
Mhm.
the model. And
Yeah.
then sort of when, when we're bridging all these like new concepts together, that, if you bridge two concepts that they learn together, you can get very close to new frontier concepts. So for example, we were doing steerable CNNs, or we are doing them right now. And then we've also been doing vision transformers. And so if we bridge those two topics together, we can get steerable vision transformers, which although the previous topics were like pre-2020, I think Vision Transformers was like in 2020. When you bridge the two together, you got a topic that was new in like 2023 or 2024. And if you
Hmm.
start bridging more and more topics together, you'll see that you get closer and closer to like the newest topics in machine learning. But our goal is basically to give them the good enough understanding that they can understand the math and like the why, and then also like how to implement it in code and how to train it. Um,
Yeah.
because that way, they can start thinking about like new architectures or new approaches to certain existing problems. Uh,
Yeah. 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 That makes sense. So yeah, but I think that's I would say like as I said, this fine-tuning mechanic is going to be very interesting, and how to make this training very stable, it would be very interesting too. And among a bunch of the topic I would talk about before, like all including the synthetic data generation, these are all going to be the foundation for future machine learning trainings. And I think worth some time to look into to get some basic idea at least.
thank you. And then our last question is, does Microsoft offer any opportunities for high schoolers that you think might interest our organization members?
That's actually a very good question. At this point, I don't think we are hiring high schoolers directly. We do start hiring like first year, second year, college students to the company to start working with us. Um, I guess there might be some other legal issues to go around, but I did also like in the industry, I did see that people start hiring um, like uh, um, how to say, high school student direct into a company. I know there's a company already did that because they feel like with the advance of AI or stuff, I mean, it's all about whether you are smart enough and whether you are really eager to learn more. Lots of stuff you learn in college is probably not necessary to be something you need for your success in the future. So, um, yeah. So things could happen in the coming years, I would say.
Thank you. Yeah, no, I was also asking like if you guys, I know that I don't know the sort of like programs that Microsoft offers because I know like we're trying to register for 501(c)(3) status, and I just was wondering if like Microsoft had any like research grants or something like that, as well as like like if there's like current existing like job things. Obviously not for like high schoolers, but like in the future. Because most of our organization members, they're uh like most of them are like juniors or seniors, so they'll be graduating this year and then they'll be going into college, and so I was just curious about that.
Yeah, yeah, yeah. I think we don't have a fund towards high school organization directly at this point, but I won't be surprised if there's anything coming out because there's a training industry where actually towards younger kids and talents, and it's definitely possible.
Great. Thank you so much. Does anyone else have any questions? Uh, okay. No, I think
Yeah.
that's it. Thank you.
Yeah, I don't see anything in the chat, Felipe.
Okay. Great. Thank you so much, Mr. Jian. And yeah, thank you for everyone for attending. We will be posting the video on YouTube if that's okay with you, Mr. Jian.
Yeah,
Okay,
cool. Thank
perfect.
you so much to having me.
Yep. Thank you so much. Bye. Thank
Great.
you.
Thank you very much, Ms.
Thank
Young.
you.
Thanks, everyone. Have a great day.
Bye. Have a great day.